for what's going on. Okay, we're going to start on 6-2 today, but before we do that, let's do a little bit more review for our test. So on page 261, starting that review section, try number 9, number 12, number 21, and number 25. And then we'll go over those and start the new lesson here in just a second. We're having loads. Okay, so for number 9, y'all bear with me. I'm going to try to go through these pretty quick. For number 9, we had the point -3, 9, and x -12. Now, this is just one way you could set it up, but when it's a direct variation, it's proportional. So we could do the -3 over 9, x over y, equals x over y again. So we would put x over -12. So -3 is to 9 as x is to -12. Other ways, I heard somebody else say that they did -3 is to x as 9 is to -12. That should still get you the same answer. But let's focus on this one. So we've got 9 times x is 9x, and -3 times -12 is what, y'all? 36. Divide both sides by 9. X is 4. Okay. So just a reminder on the direct variation. When we went over that, it was y equals k times x, and you all realized that k is essentially what? Slope. So, and notice you all are very familiar with slope-intercept form now, y equals mx plus b. What was distinct about the direct variations? Essentially, there's no plus b, right? Because that's understood to be plus 0. Yeah, so they were just lines that went through the origin. So that was all that was special about those. Okay, let's move on to 12. Here you have the slope is -7 and b is 1/2. So if you're using y equals mx plus b, Isaac, how would you write this equation? We're putting in, substituting m and b, essentially. There you go. That's all you had to do for that. So if I give you the slope and I give you the y-intercept, please don't make that too hard. Those should be easy points. Okay, good job on that. 21. Now look at, oh, we didn't get done. Sorry. Y-intercept of 1/2, and then with a slope of -7 over 1, that would be down 7. So 1, 2, 3, 4, 5, 6, 7, and then right 1. Or the opposite would be up 7 and then left 1. So 1, 2, 3, 4, 5, 6, 7, left 1. And then you have this beautiful line for your notes. Isn't that lovely? Oh, that's a really steep slope. Okay, 21. No, actually, with a negative slope, think from left to right, it's going down. And that one's going from left to right on the x-axis, it is going down. Oh, no. I'm sorry. The green is the x and y axis. Sorry. Yeah, if you're colorblind too, that's really a nasty mix of colors. Yeah, sorry. I don't know if I've ever told y'all, my husband's colorblind, and so there are certain colors that throw his life into disarray. So if you ever see me out with my husband and he is really badly color coordinated and dressed, it's because I didn't catch him before he left the house. But I think he's blue-green. Yeah, honestly, I should have caught him. Sorry. How about I pick a different color? I don't have, I've got, ew. I could do this color. Ugh, I can't do it today. Sorry. I will do this one. This one vibes better. Okay, look at 21. What can you all, okay, what is the y-intercept on 21? Looking in your book at page 261. Okay, y-intercept of -3. Looking at this, y'all, because we can do this. We can do this. You can see it better in your book. But for your slope, do you see that we're going up 1 and right 4? So that is a slope. Yeah, a slope of 1/4. So then that equation is just y equals 1/4 x minus 3. I gave you one that was way too easy. I did it the hard way.
Yeah,
no.
No, I said y equals negative 3x plus 1, 4.
Oopsies. Okay, I'd probably take off a point because you just got them backwards. Okay, 25, we have negative x plus 3y equals negative 15. Helps if you can see it. They want the x and the y-intercepts. So let's start there. Now, you all know I like to just cover them up. But if we're going to be just really technical, we can say let y be equal to 0. And that's going to give us negative x plus 3 times 0 equals negative 15. But if you covered it from the get-go and went straight to negative x equals negative 15, that is fine too. So if negative x equals negative 15, what does positive x equal? 15. Yeah, so there's one. And now same thing, we're going to let x be equal to 0. So we have 3y equals negative 15. So what is y? Negative 5, negative 5. All right, so when you graph those, okay, I don't have much room. Y'all have more room than me. So I'm going to have to go by 5s to make this fit. Okay, so there's x. And then y is negative 5. Oh, this is bad. So here's your y-intercept at negative 5. Your x-intercept is 15. And then you would just draw a line through that.
So tall.
Yeah, I wasn't thinking ahead on that now, was I? So anyhow, there you go. Good?
I feel like really lucky when graphs like this. Yeah. This one, I just decided to make the right of the x really long. And it just happened to work out. And I was like, okay, go ahead.
Yeah. And in this case, I made the y-axis really long and it did not work out. So I have a really lopsided looking graph, but okay, let's do this. Now listen, I'm going to say I like graphing, but there's just sometimes that it's not practical. And I'm going to show you. Here, let's go ahead and get this. 6.2 is titled Solving Systems, huh?
Books.
Yeah, I think so. I think you're good. I know y'all have limited room too. Solving systems using substitution. A lot of S's in there. Solving systems using substitution. There we go. Okay, so just to kick this party off, let's say we go ahead and review, and I give you y equals 3x minus 6. And then I give you y equals negative 7x plus 1. And since in this chapter we have only been graphing so far to solve a system of equations, let's try it and see what happens. A system is where you've got more than one equation, and your solution has to make both of them, or all three of them, or whatever, true at the same time. Look back through your notes. I think it will come back to you. Y'all are smart cookies. Welcome. Okay, take a minute, get those graphed. On dot paper, I'm trying to make this a little bit more obvious. Okay, I'll tell you what, Katie, for y equals 3x minus 6, would you remind me how to graph that?
You go to negative 6 on the y-axis.
Yep, negative 6 on the y-axis. Perfect. Then what would you do?
Then go up 3 and 1.
Yep. Up 3, right 1, up 3, right 1. Beautiful. Okay, so again, with graphing, we know to be really careful and try to get those lines exact because we're looking for a point of intersection. Okay, now, Heidi, would you remind me how to graph y equals negative 7x plus 1? Yeah, right there.
You go down 7 and right 1. 5,
6, 7, right 1. Perfect. Okay, that's enough. Good job, ladies. Okay, and again, you're very careful. Okay, so look really closely at that. What is that point of intersection? Can you tell? Well, we can't say 1 because it's not all the way over. Okay, let's guess. It's not all the way over to 1, so maybe 3/4 over. And then down, mine's crossing a little past -4. So I'm going to say -4 1/4. That's a lot of guessing for something that's supposed to be really exact. Math can be very precise, and this is not. So that's why I wrote guess beside it. Now, what we're going to do today, I'm just going to go ahead and show you this one, and this gets a little bit nasty, but we're going to be exact. Do you notice how these are both equal to y? If they're both equal to y, then they should be equal to each other. So what we can do is we're going to substitute that in for y, since it's equal to y. And we're now going to have 3x minus 6 equals -7x plus 1. Okay, I'm going to stress that one more time. Since they are equal to y, they should be equal to each other. So you can set the equation up that way. Or since 3x minus 6 is equal to y, we're just going to substitute 3x minus 6 in for y. Whichever way makes more sense to you. And now let's start solving. You all are good at this stuff. I don't like that -7x, so I'm taking it over to the other side. Plus 7x plus 7x. Okay, you don't have to write this, but I'm going to be thorough and go ahead and write it. So 10x minus 6 equals 1. Julia, what would you do next to solve for x? Yep, plus 6 gives us 10x equals 7. Then what would you do to solve for x now, class? Beautiful. So x actually is 7/10. We guessed 3/4. Yeah. Not so good.
I guess 0.8, so you know
Oh. Fine, fine. You all knew it. I did not. Slacker. Okay, so, well, fine. We'll see how well you did on the second one, ladies. Okay, so once you get one of your variables, go back up to your equations and decide which one looks better to substitute x in. Neither one of these are very nice. I'm going to go with y equals 3x minus 6. I'm going to bring this back down, okay, so y'all can see it better. And now we're going to substitute x in. Y equals 3 times 7/10 because 7/10 is x minus 6. Let's keep cleaning that up. Nothing cross eliminates here. So 3, and put it over 1. 3 times 7 is 21. 1 times 10 is 10. Ick. Okay, so I'm going to put 6 over 1. Remember all this fraction work? You cannot subtract fractions unless they have the same denominator. So I'm multiplying 6 by 10 over 10. And that gives me minus 6 times 10 is 60 over 10. Woo! So we have a denominator of 10. What is 21 minus 60?
40, no, 39.
-39 over 10. Is that what you all were thinking for the y value when you guessed?
Yeah.
Okay, yeah, sure. Yeah, calculator is nice in this case. So my guess was this. Apparently the rest of the class guessed better than I did. But the actual is 7/10 and -39 over 10 is -3 and 9/10. So we were in the ballpark. I was in the ballpark. I think you all were closer in the ballpark than I was, but there's the actual. So got a nose for math.
Hey, I called it 4, so.
Fine. But okay, so my whole point is graphing, at least by hand, to get the equation is not always practical. Now, Isaac also put it on the graphing calculator back there, and he got the exact, but there you go. So sometimes we need another, here's another S word for you, another strategy. And this is where substitution comes in. It's not necessarily my favorite, but it has times where I really like it. So here we go. Sometimes we need another strategy. Nope, sorry. Sometimes, let's go back. Sometimes we need another strategy besides graphing to get the solution to the system.
Wait, was that what we just did, Graham?
Yeah, we graphed and tried to come up with the answer by graphing, and we did not get close enough.
But then that equation was another.
Yes. I'm sorry. This, I went ahead and showed you one version of substitution. So this is it. This is an example of substitution, if you want to write that. Okay, and I'm actually going to give you one that I think is a little bit prettier to try the same way before I show you more substitution. Can I keep going? Okay. So you will have obviously problems that say solve by substitution. And I tell you what, in our notes, I will have you check, but listen to me. I will not make you do it in your homework. Okay. But I want you to know that you can check yourselves this way if you're ever on a test and you want to know for sure. But example 1, let's do y equals 2x plus 1 and y equals x plus 3. Again, this is a system, so the solution has to make both true. So very similar to the other one, what you can do in this case is since they are both equal to y, they are equal to each other. Okay, so I'll tell you what, Katie, just go ahead and tell me what you would set up for this. Okay, and then I'm sure you would subtract x on both sides, get x plus 1 equals 3. Then what would you do to solve for x?
Subtract 1 from both sides.
And x equals 2. And again, you all, I think you're to the point that you don't have to show me that and you don't have to show me that, but do go from here to here and then here to here, and I can follow you now, okay? But if it helps you to do the minus x, the minus 1, put it on there. I don't care. So x equals 2, and then at this point, you've got one of your answers. Think of this as a puzzle. You're trying to find the ordered pair that's going to be the solution to both of these. So x is 2. Now, what do we need to find now? Y. So pick whichever equation you think looks easier. First or second, class? Yeah. Well, actually, I'd pick x plus 3, but it works here too. Isaac, what's your question?
X equals 2x minus x, which is just 2.
Hold on, let me go back. And y'all, if I have messed up, tell me. Here, I wanted to move this x over. So I did minus x. Oh, hold on. So that gave me x plus 1 equals 3. And then I wanted to move this positive 1 over. So that was minus 1. So I got 1 minus 1 is 0. So just the x. And then 3 minus 1 is 2. Yeah? Okay, making sure. I can go back over it later if I need to. And then, of course, we've got every ordered pair is xy for the Cartesian coordinate plane. And now go back and we're going to substitute in x for either one of these equations. Somebody said the top, but I'm just going to show you get the same answer by doing y equals, now y'all, what is x? 2. And 2 plus 3 is 5. So did you all get 2, 5 as your answer? Did I go too? I must have gone too fast. I'm getting looks. Okay. Okay. So now again, I'm not going to make you, but for your notes, I want to show you that this checks out. Okay. So we're going to put 2, 5 in for both of these. So 5 is going to go in for y and 2 is going to go in for x. So does 5 equal 2 times 2 plus 1? Okay. Yeah. 4 plus 1 does indeed give us 5. I'm going to stop there. You get the idea. Now go to the second one. Again, y is 5. Does 5 equal x is 2 plus 3? All I did again was substitute in the 0.25 here. Does 5 equal 2 plus 3? Yeah, so it made both equations true. So that's what you're doing. And instead of graphing this time, we're going to solve for those points algebraically. So you got that. There's two examples of how to do that one. But we wouldn't want y'all to get bored. So here we go. This is exciting. Now we've got y equals 2x and 7x minus y equals 15. This is your system this time. This one's a little different in that we don't have two that both say y equals, right? What do you think, Isaac? Good question. You could. Now, theoretically, you could, but I think it's going to take you more work if you put this one in y equals mx plus b form. So, and I think you all are all about the most efficient way to do things. Am I right? So what you can do here, notice we have y equals 2x. So just take that 2x and substitute it in for y in the other equation, right? Okay, sorry. Okay. I mean, they're equal to each other, so 2x should be able to go in for y. So now rewrite that second equation, 7x minus, now y'all, what is y equal to up here? 2x. So just put 2x in for y equals 15. Again, all I've done is substituted something. They're equal to each other, so it's a legal substitution. Okay, and so now, well, I didn't even need parentheses here. What is 7x minus 2x? 5x. What's the matter, Katie? You're not looking like you enjoy this.
Like 5y, like 7x minus 5y.
Okay, in that case, you're going to have to solve one of them for y or x. So whereas, okay, this time we didn't need to solve for y because we already had y equal to something. But in a minute, we're going to have to do a little bit more work. Man, Isaac, you don't have to throw things back there. Okay, well, anyhow, just wait. I'm trying to like slowly get us to the more complicated problems. Just stick with me for now, okay? So what do you do to solve for x now? Yep, divide by 5 and x equals what? 3, okay? So again, if you think about this like a puzzle, like this is the key to the puzzle, x is 3. And you can solve for y first, okay? But now, to finish this puzzle, we need to solve for y. So take it back up to one of your equations, and I don't know if you're agreeing with me, but that looks like the easiest one. So y equals 2 times, what is x?
3.
3. What is y? 6. There you go. There's the solution to your puzzle, 3, 6. Okay. And now, just for time's sake, I'm not going to substitute it in, but I promise if you put this back in for both of these, it will make them both true. Does anybody need to see that to be satisfied? Okay, fine. I will accept your nose. Okay, but I tell you what, I do want to change it up some. And again, these are pretty simple, but I need to make a point. In this case, okay, earlier we had y equals 2x. Y was by itself. Down here, we've got x by itself. That is fine too, okay? When you've got x equals something, that something can substitute in for x in the other equation, okay? So Heidi, okay, I'm sorry. I'm always wanting to conquer the world in a short amount of time. Yes? I don't know. You good? We got y equals 6 once we substituted in x here, and we got 3, 6 for the answer. Okay.
X plus y equals 6.
And then x equals negative 3y. So I'm just showing them that sometimes you can have x by itself, and then we can substitute that equivalent value in for x in the other equation. So once I substitute that in, what would my new equation look like, Heidi? Fabulous. And y'all look on this left-hand side. We're going to simplify this. What's negative 3y plus a 1y? Yep, equals 6. Divide both sides by negative 2. And y is what? Bravo. So again, you're thinking solution. We got this time y is -3, so you can substitute that in. Now what do we solve for? X. Go back. Let's just keep it colorful. Now we're going to substitute y in for this one. X equals -3 times, what'd you say y was? -3, so what is X? -3 times -3? 9. So X is 9, it goes there. That is the point that if we were graphing these, they would do what? Intersect, okay? We're just, again, now doing it algebraically. Okay, they do go up a little bit more challenging, so hang in there with me. Oh, maybe a couple more. Let's keep going. Is this looking pretty easy so far?
Sounds great. Hopefully, like if they don't intersect.
We're gonna get to that. That is a great question. Yeah, hold on. That's gonna be example 3. So I've got to get through example 2 and I'll answer that. Okay, let's keep trucking. For example 2. Because I don't want you to freak out if you see one like this. Okay. We've got a system again. Do we have X equals, do we have Y equals? No. So you're going to have to pick one in this case. Generally, what I'm going to say is, okay, first solve for a variable. And I'm going to say the easiest is 1 with a coefficient of 1. Now, you all know how to solve for a variable, okay? But I'm just saying the easiest way is to look for one that has a coefficient of 1. Yeah. I would say this one's the easiest, like Julia said, because we have a coefficient of 1. Your second easiest, if you didn't have that, would be -1. And then after that, yeah, it's just going to get kind of crazy. Y'all ready? Let's go ahead and solve this one. Solve for y, okay? And you don't have to write as much as I am. I'm just trying to be thorough. How are we going to solve for y in this case? Think y equals mx plus b. Yeah. Subtract 2x from both sides, you get y equals -2x plus 8. That's beautiful. Okay, so now we have used the second equation to solve for y. And now we're going to take, I'll do this in a different color, what y is equal to, and we're going to substitute it into y in the other equation. Okay? Don't solve for y and then substitute it back into itself, or it's going to mess you up. You won't get the right answer. Solve for y or x in one equation, and then substitute that value into the other equation. Okay, so Isaac, would you tell me how you're going to substitute that into the other equation? Okay.
-2x plus 8 equals -2x plus 8.
I'm not sure what you just said there. I'm sure it made sense in your head, but I'm missing it. No. Right. We don't want that. So let me stress again. If you solve for a variable, for example, in the second equation, make sure that you substitute into the first equation or vice versa. So we've got to involve both parties here, okay, to make this work out. Okay, so we've got 3x minus, now, y is a binomial here, so we're going to have to use parentheses. What is y, Isaac? Good job. Equals 17. Okay, now if that's not clear, your original was 3x minus y equals 17. I just substituted -2x plus 8 in for y. Okay. Say it again. Okay, you can. Okay, so now just be careful. What is 3x minus a -2x? Minus a negative becomes plus. So this becomes plus 2x. And then minus a +8 just becomes minus 8 equals 17. Okay, so essentially it's like you're distributing a -1 if that's messing with your head. It's just changing the signs of both. So now, y'all, what is 3x plus 2x? 5x minus 8 equals 17. And again, y'all know how to do this. Just go ahead and clean it up. Add 8 to both sides. You get 5x equals 25. Divide both sides by 5. You get x equals 5. Fabulous. So again, looking for the answer to the puzzle, we have x is 5. Now what do we do? You got it. Solve for y now. And again, you can make this more complicated than it needs to be, but here's what I would do. Since you got y equals -2x plus 8, that's where I would go for y. So y equals -2 times what is x? 5 plus 8. That's your easiest route, is to plug it back in there. So we get y equals -10 plus 8. So y is what, class? Fabulous. Again, and if you've done it right, you can substitute that answer into both equations. It makes them both true. Okay, finish that up and we will go on to example 3. Was that too bad? Okay, I'm like, y'all can handle this without a doubt. Okay, example 3. Now we've got, oh, I didn't do a B. Sorry, we're out of time. I would give you another one, but I think you can handle it. Y equals 3x plus 2. And then we've got 3x minus y equals 2. Okay. Are y'all seeing what I'm saying? We have a y equals. So let's go ahead and substitute 3x plus 2 in for y in the other equation. Yes. We're about to find out. But yes, I like how you're thinking. Good job. So if you don't notice that those are essentially the same lines, kind of rearranged, the same equation, this is what's going to happen. We've got 3x minus, now y is equal to 3x plus 2, so we're substituting that in for y, equals 2. Okay, so again, distribute that negative, 3x minus 3x, and then minus a 2 equals 2. Notice your 3x minus, oh yeah, you're fine. 3x minus 3x is 0. So we get -2 equals, oh, I wrote the problem down wrong. We could go ahead and go with this, but I think I did one of each. Go ahead, y'all, fix this real quick. This is supposed to be -2, and I wrote it down wrong. Sorry. Thank you. Catch me on that. Yeah, my bad. So I was trying to get to one that was exactly the same. So that should have been a -2. So when you get down to the end, you get, okay, again, we've done this before with solving equations. When that variable completely goes away and we're left with just constants, ask yourself, is it true or false? Is -2 equal to -2? Yes. So essentially, I wrote the problem down wrong, Katie, so just fix it. When that happens, when true.
But if you keep solving, like, because you still have the 0x there.
That when you get that 0x and there's no y, that should be like a major warning sign that you've got parallel lines or you've got the same line where they're graphing right on top of each other. Okay, so when this happens, this is the same line. And it is, okay, and this is where the answers can turn out different. I think your book says infinitely many solutions. Some books will say any point on the line y equals 3x plus 2. Okay, because the point is when you graph these, they're graphing right on top of each other. They're touching every point along the way. Okay, so it's the same line. So I think, like I said, I think your book might say infinitely many solutions.
Yeah, I think it does. Look at the one.
Okay.
I think, right?
I have to look. There you go. So just put that. Okay, you good on that one? Okay, then let me just Wait, say that again. Yes, sorry. You know me, I'm always in a hurry. Thank you for slowing me down. I'll tell you what, we're gonna run out of time for more homework questions, so please, please, please just get on Zoom with me tomorrow and I'll answer as many as I need to. Yeah, I goofed. I told them that should have been a -2 from the get-go. If you will remind me, I will.
It starts from-
At 10:30, just send me a text. Okay, let's keep going. So y'all, let's say you are trucking through your homework, you get 3x plus y equals 5. You get 6x plus 2y equals 1. Oops, sorry. 3x plus y equals 5. 6x plus 2y equals 1. Y'all, there's so many ways we can tackle this. What do y'all want to do with it?
So,
You got it. We're going to substitute now. Okay, my brain would probably go, oh, I see a y with a coefficient of 1. So I'm going to go ahead and solve that by moving that 3x over. Do y'all agree it's y equals -3x plus 5? Yes? Okay. So now that I've got y solved for, I'm going to take the 3x plus 5 and substitute it into the other equation. So stop me if I'm not making sense, y'all. So now we've got 6x plus 2 times. We found out y is, oh, I just messed that up. -3x plus 5, sorry, equals 1. And then you're just rocking along through this problem. 6x, distribute that. 2 times -3x is -6x. 2 times 5 is 10. And then looky there, the 6x minus 6x gives us 0x. We're not even going to put the x. So we get 10 equals 1.
yeah.
2 times 5? 10? Yeah, tell me if I mess it up. But when this happens, again, ask yourself, true or false, does 10 equal 1?
Yes.
No, 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 no. So in this case, they are never going to cross. This is no solution because essentially they are parallel lines. Feel free to graph those if you want to. We're out of time. I can't do it. Okay, so that's what happens. Okay, I'm going to stop there. I think I've given you one of everything I can think of that will happen. So practice 6-2 example. Please do numbers 1 through 33 odd. They give you about 15, 16 to do. Let me think for a minute.
That's someone saying.
Well, I know.
Today's homework could just be going over our entire notes.
Yeah.
Or,
chapter 5.
or
I completely
you
agree.
can save yourself some Zoom time if you just do that one.
I have co-op tomorrow, though. I mean, I'm always down for no Tuesday work.
Oh no. I'm thinking.
I've got to write this thing. I haven't even finished it yet, so you know. For the sake of me.
Okay, I'll tell you what. For real. And part of this is because, yeah, I've had a lot of technical issues lately. Ugh, that's recommended, not recommended. Put an N in there. Recommended, optional.
Okay, I'm sorry, I sounded.
Is I'm gonna say page 261, numbers 1 through. I could probably do extra credit. If anybody's needing it, this is extra credit, but you better show your work and check it and get help if you don't know how to do it. Got it? Okay. I'll even say odd. But that is the review at the end of chapter 5. And I do think that would be helpful for you to do, to practice for Wednesday's test. Now, y'all, I'm going to ask for somebody to help me on this. I would like you on Wednesday to get here half an hour early. Would some good soul please send me a message?
So I don't forget.
I can-
Yeah, can you set
I can-
yes. Yes, please send me a text that says, please, Miss Whitaker, don't forget about us. I love that feature. So please show up half an hour, 12 on the dot, noon. Don't be a minute later so we can get in elimination, which is my favorite way to solve systems of equations, okay? We still need to do a lesson on Wednesday, but I also want you to have time to take your test. There you go, 12 noon on Wednesday. Show up for the test. Let's be done with chapter 5. We're out.